Hello, I am Seema and welcome to part 6 of the chapter Solutions. In part 5, I told you about normality. The topic of this video is also normality, and in this video I am going to solve 4 numerical problems on normality so that you understand the topic better. Let us start with the problems. The first question is that you have to calculate the normality of 60 grams of sodium hydroxide in 1000 milliliters of water. Remember, whenever we solve a numerical, whatever is asked, we first write down its formula or its definition. If you have that in mind, then you can always arrive at what is required. So we know that normality of anything is equal to the mass of the solute upon the molar mass of the solute upon the equivalent, or upon the equivalent weight, we should call it, which I'll say is molar mass of the solute, that is B, upon its basicity or acidity, depending on whether it's an acid or a base, or the charge on the cation if it's a salt, into the volume of the solution in liters. And if the volume of the solution is given in milliliters, then this becomes milliliters, and you multiply this by 1000 in order to convert the liters into milliliters, right? So this is the equation for normality. You've been asked the normality of 60 grams of NaOH. That is, WB is 60 grams. It is given to you. WB is equal to 60 grams, right? And the volume given to you is 1000 ml. And you're supposed to find out the normality. In order to know the normality, you must know the molar mass of NaOH and you must know the basicity or acidity. NaOH has OH ion, therefore it's a base, so it has acidity. And what kind of, is it a monoacidic base or is it a diacidic base? Since there is only one OH negative that is replaceable, or one hydroxyl replaceable hydroxyl ion, therefore it is a monoacidic base. Since it is a monoacidic base, therefore the basicity, acidity of this is 1, right? So we need to find out the molar mass. The molar mass of NaOH is to be calculated. The mass of sodium is 23, oxygen is 16, and hydrogen is 1. So the mass of sodium hydroxide, the sum of all these comes out to be equal to 40. And the acidity of this base is 1. So let us just substitute all these values in the equation. So normality would be equal to mass given is 60 grams upon the molar mass is 40 grams per mole upon acidity, so you multiply this, whatever is the denominator of this becomes the numerator, so into 1, and the volume given is in milliliters is 1000 milliliter. And since it is given in milliliters in this equation, so the 1000 and 1000 get cancelled, and 60 gram over 40 gram would be equal to 1.5 normal. So that's the solution of this question. How do you find out the normality? What did you do? You wrote down the mass, whatever was the given mass, divided by the molar mass of the solute, divided by, or you could write, instead of writing it divided by, you could put into here acidity or basicity or the charge of the cation of base, acid and salt. And into 1000 if the volume has been given in milliliters of the solution, and remember here it says 1000 milliliters of water. And since we are adding a solid to water, there is not much of a difference that will occur in the volume of the solution. Therefore, we assume the volume of the solution to be the volume of water, assuming that the sodium hydroxide which has been added would disperse in the same volume in the intermolecular spaces of water. So that was question 1. The next question is, you have to calculate the normality of 9.8 grams of H2SO4 in 250 milliliter solution. Again, it's similar. The equation, you have to write normality is equal to the mass, this time I'll simplify this further, into basicity or acidity or acidity of the base, and in this case, since it is H2SO4, it would be the basicity of the acid, so let us not write the other values, into basicity upon the molar mass of solute, that is H2SO4. So W, the weight of H2SO4 we could have written, which is the solute here, and into 1000, because the volume has been given in milliliters, into the volume of solution in ml, right? So let us substitute the values. In order to substitute the values, first we need to find out the molar mass of H2SO4. So let's calculate the molar mass of H2SO4 would be equal to, H is 2 hydrogens, so the mass of one hydrogen is 1 and there are 2 atoms of hydrogen, plus there is 1 atom of sulfur and the mass of sulfur is 32 into 1, plus there are 4 atoms of oxygen and the mass of oxygen is 16 into 4. And when you calculate this, this comes out to be equal to 98, right? So now we'll substitute, and since H2SO4, what is the basicity of this acid? It has 2 replaceable hydrogen ions, therefore its basicity is 2. So we'll substitute the values now. Normality of H2SO4 would be equal to, the weight of H2SO4 is 9.8 grams divided by, into the basicity, what is the basicity? 2 into 1000 is the numerator, upon the molar mass is 98 into the volume of the solution in milliliters given as 250 milliliters, right? So this gets cancelled, this is 4 and 9.8, this is into 10. So when you solve this, you remove the decimal, you got a 10 here, and 98 and 98 get cancelled, and when you solve this, this comes out to be equal to 2 4s are 8. 8 upon 10 makes it 0.8 normal. The unit is normal, right? That is gram equivalence per liter of the solution. The unit normal means it is gram equivalence in a liter of solution. So this is the normality of H2SO4 solution. Let us now do 2 more numerical problems. Give me a moment to write them down and then I'll explain them to you. So here's question 3. The question reads, what is the normality of a solution of 23.8 grams of H2SO4 in 1.25 liters of solution? Again, we know normality is equal to the molar mass of the solute, that is H2SO, the weight of H2SO4 solute upon molar mass of solute into, this is an acid, therefore it will be the basicity of acid or the hydrogen ions, into the volume of the solution. Since it's given in liters, we do not have to put the 1000. Volume of the solution in liters, right? So we need to calculate the molar mass of H2SO4, which we calculated in the previous problem. It is 98. So using that, and the basicity of H2SO4 is 2, we just did it in question 2. So let us substitute the values and find it out. The normality therefore would be equal to, the mass of H2SO4 given is 23.8 grams of H2SO4 and basicity is 2, divided by the molar mass is 98 grams per mole, and volume of the solution in liters is 1.25 liters. And when you solve this, you get the normality would be equal to 0.388 normal. 0.388 normal would be your answer when you solve this, right? Now there is one thing that you have to pay attention on. What is the difference between normality and molarity? Molarity is given as, the formula for molarity is the number of moles of a solute. And how do you calculate the number of moles? The number of moles of solute upon the volume of solution in liters, right? The number of moles is calculated by mass of solute, that is, in this case it is H2SO4, upon molar mass of H2SO4 into volume of solution in liters, right? So what difference do you see in normality and molarity? The difference between normality and molarity is only of the basicity or the acidity of the base or the charge on the cation in the case of a salt. Therefore, if in a question you're given molarity, it is possible to calculate the normality just from the molarity. How? All you have to do is multiply this value, the normality, by 2. Or if you have to calculate the molarity from the normality given, you will divide it by the basicity or acidity and you'll get that value. So let us try this. If we had calculated the molarity, what would we have got? The molarity of this H2SO4 would have been equal to, the mass of H2SO4 given is how much? 23.8 grams divided by molar mass is 98 grams per mole. And the volume, so the grams and grams will get cancelled, the mole will come up, you will get moles per liter, which actually is molarity or molar solution. And into the volume of the solution in liters is 1.25 liter. And when you solve this, you get how much? What's the value that you get? 0.194 molar. 0.194 molar is the answer that you would get. And all you have to do to get normality from molarity would be, you would multiply this by the basicity of this acid. Since it is H2SO4, the number of replaceable hydrogen ions is 2. So multiply this by 2 and it will come out to be equal to the same value, that is 0.388 normal. Right? So there are two ways how you could have solved this. Either by directly putting the formula and finding out the normality, or by finding out the molarity and then multiplying the molarity with the basicity of the acid. You would not really, this would not be your first preference. But if in the question you've been given the molarity, or in a previous step you were expected to calculate the molarity, then you could use this formula at that time. That you already have the molarity and from that you want to calculate the normality, or vice versa. You have the normality and you're supposed to calculate the molarity from it, you would divide it by the basicity or acidity. So this is the relationship between molarity and normality also. Now we come to the last question for this video. The question is, okay, where do we use such a kind of question? You would get such questions in stoichiometry. And you know, when you talk of molar solution, it is the number of moles of any substance in a liter of solution. But in a neutralization reaction, in order for a reaction to take place, you need equimolar H positive and OH negative for neutralization, right? For any reaction to take place, for any neutralization to occur, the number of H positives should be equal to OH negative so that they combine and they result in the formation of water. Let me just remind you of what neutralization was. Any acid is an acid because of the presence of H positive, let us say HCl. And any base is a base because of the presence of the OH negative. And Na is positive here, Cl is negative. So what is neutralization reaction? The H positive of the acid and the OH negative of the base, which are responsible for their acidic and basic character. Both of them combine to result in the formation of water. HOH would be water. And the Na and Cl, they result in the formation of a salt. Right? Such a reaction is known as a neutralization reaction. When will neutralization occur? When the number of H positives is equal to OH negative, so that neither H positive is in excess or OH negative is in excess, then the solution is neutral. Let us say you had H2SO4, 1 mole of H2SO4 and 1 mole of NaOH, or 1 molar solutions of both of these. 1 molar means 1 mole of this per liter in the liter. Now what will happen in this reaction? You will get Na2SO4 is the salt that you will get, but the H2, now this will not be balanced. The H2SO4, the water, you will get H2O, half of the H ions will be used up because it has, and the other half of H2SO4, the excess, you will have 1 mole of H positive ions which have not reacted because they are excess. So neutralization will not occur. In order for neutralization to occur, the number of moles of the H positive and OH negative should be equal. But if you take equimolar solutions, this will not happen because it has one mole. You've not taken into consideration the basicity or the acidity of the base. And in those cases, normality, this value, this measurement becomes more important because it equalizes the number, one normal of one solution and one normal solution. For example, let us take one molar solution of H2SO4 and one normal solution of H2SO4. One molar solution of H2SO4 will have 2 moles of H positive ions, but one normal solution of H2SO4 has only 1 mole of H positive ions. Therefore, this, when you take normality, it equalizes the values of positive, that is H positive and OH negative ions. Why am I telling you this story? The story I am telling you because this gives us a very simple formula when you are talking about neutralization reactions. Now, the question is that what volume of 1.7 normal H2SO4 solution is required to completely neutralize 50 ml of 1.3 normal NaOH. You remember when we did dilutions? We said M1V1 is equal to M2V2, right? When the volume changes, the molarity changes in such a way that the product remains the same. Now, in this case, the normality of both the solutions and the volume, if you multiply those, that is N1 V1 is equal to N2 V2. Now, this is not a dilution. It is a reaction, a reaction in a certain stoichiometry, right? But the normality is rendering them of equal power as acid and base, because H positive and H negative, if both the normalities are equal, then they would be equal in their normality. That is, number of H positives and OH negatives would be the same. So in order to do that, one of this can be an acid. That is, N1V1 is for H2SO4 and N2V2 is for NaOH. So this value, this equation should be valid for a neutralization reaction of this kind, where the basicity of the two or the acidity of the acid and base may not be the same, yet N1V1 would be equal to N2V2. Because N1V1, when you have the same normality, the number of the displaceable cations and anions, automatically their strength becomes equal. So here, when we put this value, let us see what is the normality. 1.7 is the normality of H2SO4, N into what is the volume given? Volume is to be calculated, V1 or VH2SO4 is to be calculated, is equal to the normality of 1.3 normal NaOH solution, and the volume given is 50 milliliters. From this, you're supposed to calculate the volume of H2SO4. Easy. VH2SO4 would be equal to 1.3 normal into 50 ml upon 1.7 normal. So the normality will cancel out, and the unit you will get is the volume in milliliters. And when you solve this, the volume that you get is 38.2 milliliters. 38.2 ml solution. So 38.2 milliliters of 1.7 normal H2SO4 solution is required to completely neutralize 50 milliliters of 1.3 normal NaOH solution. So this helps us in questions where you have stoichiometry. So where do you use questions? Where would you have questions of normality? You'd have either a simple question to calculate the normality of a solution, or you would be expected to calculate normality from the molarity, or you could use the concept of normality in solving problems of stoichiometry. And with this, I'll finish this video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.